All right, last part. We're going to talk about trigonometry and trig ratios. Trigonometry is a huge word, so let's go and break it down. Trigonometry. Trigonometry. Go and try it. Trigonometry. Put it all together. Trigonometry. All together. Trigonometry. Okay, so we're going to talk about what the heck trig is, right? And we'll talk about when solving for using our trig ratios. Okay, so we've been focusing a lot about right triangles, right? It says in a right triangle, right, we have all these sides. We talked about C, right? And across from angle C, right? That's the hypotenuse, right? And then we have leg A and leg B, right? They are the same thing, but they might have different names, okay? So it says the side that is across from a given angle is called the opposite leg. So this is called the opposite leg. So in our picture, it says refer to angle A. So here we go. Here's angle A, right? Across from angle A. This is your opposite side. I like to abbreviate it as OPP. Okay. Cool. Right? Then it says the non-hypotenuse side that is next to the given angle. This is called the adjacent leg. And we talked about adjacent going back to angles, right? Adjacent angles, and we can go ahead and review a little bit. Right? The relationship between 1 and 2, right? They are adjacent. They are right next to each other. They share this common side, right? So the next two, right? Next to a given angle, next to the relationship is I'm right next to that, right? So the adjacent leg is the leg that is right next to the angle. So here's the angle A. The side that is right next to angle A is side B. So this is the adjacent leg. And I like to abbreviate adjacent with ADJ. Okay, and then we know this, right? We talked about it last time. The side that is across from the right angle. So side that is across from the right angle is called the hypotenuse. Right, so the side that is across from the right angle, this is called the hypotenuse. I like to abbreviate as HYP. That is the hypotenuse. Okay, cool. So for each given angle, we have to label the opposite leg, the adjacent leg, and the hypotenuse. In other words, we're going to go ahead and use the abbreviations, right? So let's look at example 1. It's asking us to look at angle A. So here's angle A, right? Across from angle A, across from the given angle is called the opposite side. So across from angle A, this is the opposite side, right? The angle right next to, the side right next to the given angle is called the adjacent leg. So the side right next to the angle is my adjacent side, right? And always forever, always and forever, across from your right angle is going to be the hypotenuse. Okay, so always across from the right angle is the hypotenuse. So let's look at example 2. Example 2, we're looking at angle R. I'm going to first just take the hypotenuse out of the mix, right? Across from my right angle, this is the hypotenuse. Okay, opposite to the angle, this is the opposite side. And then the side right next to my angle, this is called the adjacent side. Okay, I want you to try the next 2 examples and come back to the video. All right, let's go ahead and look at part G, or number 3. Here's G, right? First, I'm going to start with my hypotenuse across from my right angle. That's my hypotenuse. Across from my angle, that's the opposite side. The side right next to my angle, this is the adjacent side. Okay, and let's look at the next one. We're looking at angle M, right? Across from my right angle is always the hypotenuse. Opposite to the angle is the opposite side. And the side right next to the angle, this is the adjacent side. Okay, the reason why we are doing this is because it's going to set us up for the next part. Okay, so let's go ahead and start the next part. All right, this is when we were talking about trig ratios. So a ratio, guys, is a fraction. So ratios are our fractions. Okay, so a trigonometric, that's a huge word. Trigonometric. I like to say trig ratio because sometimes it's hard to say, right? A trig ratio is just a ratio, or our fractions, of two sides of a right triangle and a related angle. So just like when we did these guys, right? All of these highlighted angles, these are my related angles. And then I have all these sides, right? We're going to look at only two sides at a time when we were talking about trig ratios. Okay, so here we go. It says, let triangle ABC be a right triangle with acute angle A, right? The sine of A, and the way that we write sine of A is like this. Sine of A is S-I-N-A. The cosine of A is C-O-S-A. And then the tangent of A is T-A-N-A. So we have three trig ratios. The first one is sine, the second one is cosine, and the last one is tangent, right? The first one is sine. Go and try saying it, sine. The second one is cosine. Go and try saying it, cosine. And the last one is tangent. Go and start saying it, tangent. Okay. Now, right, when we're looking at this, sine, it says the length of the opposite leg of angle A over the length of hypotenuse. So in this case, we're looking at angle A, right? Opposite of angle A is that leg right there. Right next to angle A is the adjacent, right? Opposite of your right angle is the hypotenuse. So for sine, it's going to be the opposite over the hypotenuse. Okay, for cosine, it's talking about the length of the adjacent to A over the length of the hypotenuse. So for cosine, it's going to be the adjacent leg over the hypotenuse. And then the tangent, it says the leg opposite of angle A all over the leg adjacent to angle A. So this one's going to be opposite over the adjacent leg. And this is what we need to go ahead and memorize, okay? There is a good way to see it. This is called SOHCAHTOA. SOHCAHTOA. It's a funky word. SOHCAHTOA, okay? Where sine, the S starts for sine. Sine is the opposite over the adjacent, what we just saw right here, right? I'm going to have cosine. Cosine is the adjacent over the hypotenuse, which is this guy right here. I'm going to change the colors. Okay, and then the third one is tangent. Tangent is opposite over the adjacent, which is this guy right here, right? We just talked about it. Okay, this is how I want us to go ahead and look at SOHCAHTOA, is these three ratios, where you're going to have the opposite leg over the hypotenuse. You'll have the adjacent leg over the hypotenuse. Then you'll have the opposite leg over the adjacent side. Okay, so let's go ahead and try the first two examples. It says find the trig ratio and write each answer as a reduced fraction using Desmos. So I'm going to make sure my Desmos calculator is ready to go. And I'm going to clear some things because, wow, that's a lot I have in my calculator. Oh my gosh. Oh no. Oh, it doesn't. Oh no. All right, let me get out of here. Okay, cool. Now it looks all pretty. Okay, so it says find the following values. It's asking us to find the tangent of angle S and the sine of angle S. So I'm going to go ahead and find angle S and I'm going to highlight it. That's my related angle. From here, I'm going to go ahead and label the opposite, the adjacent, and the hypotenuse. Right? The opposite side is 80. The adjacent side is 18. And always across from your right angle is the hypotenuse. Yes? So tangent. Tangent, I know the T is O over A. The opposite over the adjacent. So I'm going to take my opposite side, which is 80, over 18. So my ratio is 80 over 18. Before I circle or highlight my answer, I'm going to go and type in 80 divided by 18. And this little icon, that changed my decimal to a fraction. And it simplifies it. Haha. My answer is 40 over 9. Okay. Sine. Sine is opposite over the hypotenuse. Right? So opposite over the hypotenuse. I'm going to take my opposite side of 80 all over my hypotenuse of 82. So I have 80 over 82. And like I did with the tangent, let's go and see if that simplifies. Nice, it does. My final answer is 40 over 41. Okay, I want you to try example 2, at least the setup, right? We're looking at sine of S, cosine of S. So I'm going to go and highlight S. And I'm going to label the opposite, the adjacent, and the hypotenuse sides. The hypotenuse, or sorry, the opposite side. Here's the adjacent side. And across from your right angles, the hypotenuse. Cool. Right? Sine is O over H. So for sine, I'm going to do O over H. The opposite side over the hypotenuse. So I'm going to take 63 all over 65. And let's see if that reduces. This one does not, so this is your answer. Okay, now I'm going to look at cosine. Cosine, the C stands for cosine. It's the adjacent side over the hypotenuse. So I'm going to have the adjacent side over hypotenuse. My adjacent side is 16. My hypotenuse is 65. I get 16 over 65. And let's see if that reduces. Nope, this one does not reduce. Therefore, that is my answer. Okay, let's keep on going.